Yes, can you hear me?
Yes.
Walaikum assalam. Can you start? Okay. Yes, good morning to all. Myself, Shoaib Pirzadeh, Assistant Professor, Milia College, Bid. As in the last period, we have completed thermodynamics first, and today we solve some numerical problems on this topic. So we see the formulas. What are the formulas that is which are used for solving the problems? As the first formula, that is the first law of thermodynamics, that is the mathematical formula for first law of thermodynamics, that is Q is equal to delta E plus W. You remember this formula, that is the first law of thermodynamics, Q is equal to delta E plus W. Now what is Q? Here Q is, that is heat, delta E internal energy, and W is work done. Therefore the formula for first law of thermodynamics is Q is equal to delta E plus W, where Q is heat absorbed, delta E is internal energy, and W is, that is the work done. Now for isothermal process, for isothermal process, that is delta E, the value of delta E is 0. So put the value of delta E is 0 in this above equation, we get, that is Q is equal to W, because delta, the value of this delta E is 0 in this equation. So for isothermal process, that is the value of Q is, that is W, or heat absorbed, is equal to work done. So this is the one formula, that is first law of thermodynamics, Q is equal to delta E plus W. Now next, an important formula, that is work done. Work done in irreversible process. We have seen work done in both reversible as well as irreversible process. So work done in irreversible process, that is W is equal to P into delta V. We have proved also that equation, that is W is equal to P into delta V, where P is work done. W is work done, P is pressure, and delta V is change in volume, and V2 minus V1, V2 minus V1. So the formula is W is equal to P into V2 minus V1, where W is work done in irreversible process, P is pressure, V2 is, that is final volume, and V1 is initial volume. So this is the work done, that is in process. W is equal to P into V2 minus V1. Now next and very important, work done in reversible process. Work done in reversible process. So W max is equal to 2.303 nRT log of V2 upon V1 to the base 10. So this is the formula for work done in a reversible process. Very important. Always question is asked in examination on this bit, that is W max is equal to 2.303 nRT log of V2 divided by that is V1. We have also prove this, that is W max is equal to 2.303 nRT log of V2 upon V1, where W max, that is, it is work done. V1 is initial volume. V2 is final volume. Small n number of moles. R is gas constant and its value is 8.314 joule. Sometime it is given in the problem, that is in bracket R is given. If it is not given, you remember the value, that is R is equal to 8.314. ठीक है, कभी प्रॉब्लम में दिया जाएगा R की वैल्यू और कभी अगर नहीं दिया गया तो आपको याद रखना है R is gas constant and its value is 8.314 joule. T is temperature in Kelvin. Remember, T is the temperature, but it is in Kelvin. Sometime it is given in Kelvin or sometime it is given in degree centigrade. If it is given in degree centigrade, so we have to convert in degree Kelvin. So what is the rule for converting temperature degree centigrade to degree Kelvin? Can anybody tell me? Yes, क्या रूल है? डिग्री सेंटीग्रेड को डिग्री केल्विन में कन्वर्ट करना है. टेम्परेचर बता सकते क्या कोई? क्या कितना ऐड करना पड़ता उसमें? यस, कैन एनीबॉडी टेल मी? टेम्परेचर डिग्री सेंटीग्रेड में है, डिग्री केल्विन में कन्वर्ट करना है, तो क्या रूल है उसका, या हाउ टू कन्वर्ट टेम्परेचर डिग्री सेंटीग्रेड?
मल्टीप्लाइड टू 273.
करेक्ट, वी हैव टू ऐड 273. जो भी डिग्री सेंटीग्रेड में टेम्परेचर है, फॉर एग्जांपल 27 डिग्री सेंटीग्रेड है, 27, तो इसको डिग्री केल्विन में कन्वर्ट करना है, तो क्या करना है उसमें? प्लस 273. सो जब डिग्री सेंटीग्रेड में टेम्परेचर है उसको डिग्री केल्विन में कन्वर्ट करना है, तो प्लस उसमें क्या करना है? 273. ये रिमेंबर डैट. बच्चे क्या करते हैं, जब प्रॉब्लम दिया जाता है तो डायरेक्टली जो टेम्परेचर दिया हुआ है डिग्री सेंटीग्रेड में वो एज इट इज रखते हैं, बट यहाँ पर आपको तो जो टेम्परेचर लेना है वो डिग्री केल्विन में लेना है. हाँ, डिग्री केल्विन में अगर डायरेक्टली दिया गया है तो यू हैव टू पुट डायरेक्टली, दैट इज द सेम डिग्री केल्विन का. अगर डिग्री सेंटीग्रेड में दिया गया है तो आपको डिग्री केल्विन में कन्वर्ट करना है. ओके, सो रिमेंबर दिस फॉर्मूलाज फॉर सॉल्विंग द प्रॉब्लम्स. नेक्स्ट, now see the first problem. Calculate work done when a gas expand isothermally and irreversibly from 5 liter to 10 liter against constant external pressure 30 Newton per meter square. So this is the problem. Remember that when the problem is given, so first of all, when you are solving the problem solution, so first of all you write given things, that is what is given in the problem, what quantities are given in the problem. So first of all you read the problem and then that is write what quantities are given in the problem. So I will read again the problem. Calculate the work done when a gas expand isothermally and irreversibly from 5 liter to 10 liter. See here, that is volume is given 5 liter to 10 liter. That is 5 liter is the initial volume. That is the value of V1. V1 is equal to 5 liter. And to 10 liter, 10 liter, that is it is the final volume. That is the value of V2 is given. That is V1 is 5 liter, V2 is liter. Against constant external pressure. 30 Newton per meter square. That is pressure is given 30 Newton per meter square. And what we have to find out? We have to find out, or we have to calculate the done. So W, the value of W, we have to calculate. So V1 is given, V2 is given, P is given. So which formula we have to use? That is W is equal to P into delta V. W is equal to P into delta V, or W is equal to P into V2 minus V1. V2 minus V1. The value of P is given, the value of V2 is given, the value of V1 is given. Now put the values of these in this equation. That is value of P is 30 Newton per meter square into what is the value of V2? 10 minus what is the value of V1? That is 5. So 10 minus 5. So solve this. Therefore, W is equal to 30 into 10 minus 5, that is 2. So we can 30 into 2, that is we can do the
So 10 minus 5 is 5 now.
10 minus 5. Okay, that is here we have 5. Yeah, put here
Answer.
5. 5
150
into
joule.
30, that is 300.
150.
Correct? 150, 150. So it is wrong
150.
here. So I will do correction later on. So 30 into 5. Okay, so here 30 into 5, 150. 30 into 5, 150. Remember that. So I will do the correction later on. So you, that is 30 into 5 here. 10 minus 5, 5. 5 into 30, that is the 60 joule. So we have to write the unit also. That is, what is the unit of work? Joule. MKS system. All quantities are in MKS system. So we have to put here joule. So W is equal to 60 joule. This is the first problem. Understand? Okay, next.
Yes, sir.
Now next problem. That is also the same type. Calculate the work done when a gas expands isothermally and irreversibly from 1.5 cubic decimeter, dm cube is cubic decimeter, to 4.5 cubic decimeter against constant external pressure 300 Newton per meter square. Same problem is there, only that is the values are changed here. So when we are solving, so first we have to write the given things, that is what quantities are given in the problem. So first of all, I will read again. Calculate the work done, that is we have to calculate the value of W, work done when a gas expand isothermally and irreversibly from 1.5 cubic decimeter, that is dm cube, to 4.5 dm cube. That is initial volume is given. Initial volume is 1.5 cubic decimeter. V2 is 4.5 cubic decimeter, and pressure is given. Pressure is, that is the 300 Newton per meter square. So V1 is given 1.5 cubic decimeter. V2 is given 4.5 cubic decimeter, and P is given 300 Newton per meter square, and we have to calculate the value of, that is the W. Again, same formula is used here. Work done in irreversible process. W is equal to P into delta V, or W is equal to P into V2 minus V1. Now put the values. P is, that is 300, V2 that is 4.5, minus V1 1.5. Now this is the subtraction. 4.5 minus 1.5, it becomes 3. So 3 into 300, 300s. So it becomes 900. So answer is, our work done is, that is the 900 joule. So this is the second problem. Understand?
Yes, sir.
Okay, next problem. Calculate the work done when a gas expand isothermally and irreversibly from 3.5 into 10 raised to minus 3 cubic decimeter dm cube. See here, the quantity is given somewhat large. 3.5 into 10 raised to minus 3 cubic decimeter to 8.5 into 10 raised to minus 3 cubic decimeter against constant external pressure pressure is given 3.03 into 10 raised to 5 Newton per meter square. So this is the problem. Again, that is same type of problem is given, only values, that is quantities, are different. So first of all, that is we see what is given in the problem. Given things, that is what is given. Calculate the work done. Again, that is we have to calculate the W, value of W, work done. Calculate the work done when gas expand isothermally and irreversibly from 3.5 into 10 raised to minus 3 cubic decimeter. That is, this is the V1, value of V1. V1 is 3.5 into 10 raised to minus 3 cubic decimeter. Now, to 8.5 into 10 raised to minus 3 cubic decimeter. That is, V2 is 8.5 into 10 raised to minus 3 cubic decimeter. Now, P is equal to, pressure is given, external pressure 3.03 into 10 raised to 5 Newton per meter square. P is given, P is equal to 3.03 into 10 raised to 5 Newton per meter square. So these are the values. So again, the same formula is used. W is equal to P into V2 minus V1. So P, the value of P is 3.03 into 10 raised to 5. This is the value of P, that is the pressure, into V2. What is the value of V2? This 8.5 into 10 raised to minus 3 cubic decimeter minus V1. V1 is 3.5 into 10 raised to minus 3. Now see here, 10 raised to minus 3 is common. 10 raised to minus 3 is common. So take outside the bracket. So what remains in the bracket? That is the 8.5 minus 3.5. 8.5 minus 3.5. This multiplication symbol is not there. So by mistake it is there. This is not, remember, this multiplication symbol. During writing, I am forget to, that is clear this multiplication symbol. Only in bracket 8.5 minus 3.5. Remember that. So what is the value of 8.5 minus 3.5? So it is 5. 8.5 minus 3.5 is the 5. 3.03 into 5. This 5 come from 8.5 minus 3.5. Now see here. So this I have written directly 10 raised to 5 and into 10 raised to minus 3. So here 10 raised to 5 minus 3. 10 raised to 5 minus 3 and 10 raised to 5 minus 3 means 10 raised to 2. So I have written directly 100. That is 10 raised to 2 means 100. Understand? देखिए जिसका मैथ्स नहीं है वो लोग थोड़ा सा एक कीजिए, जिसका मैथ्स है वो लोग समझ में आ रहा होगा, लेकिन जिसका मैथमेटिक्स नहीं है थोड़ा सा देखिए कि 10 raised to 5, 10 raised to minus 3. So here 10 raised to 5 minus 3, that is it becomes 10 raised to 5 minus 3, 2. 10 raised to 2. 10 raised to 2 means 100. So if you do the multiplication of this, that is it is 100 into 5, 500, and 500 into 3.03. So it becomes 1515, that is 1515. So this is the, that is 515 joule is the answer. This is the third problem. Now next. Now next is calculate constant external pressure. So see, in the previous problem, work done is asked, pressure is given. Now in this problem, see here, that is a pressure we have to calculate. That is, calculate external pressure required to compress an ideal gas from 23 into 10 raised to minus 3 m cube to 8 into 10 raised to minus 3 m cube when work obtained is, that is 4.545 kilojoule. So this is the problem. So we see first what quantities are given and what we have to calculate. So calculate external pressure. So that is, we have to calculate the value of P. We have to calculate value of P. Required to compress an ideal gas. See here, compression is there. So V1, what is the condition compression? V1 is greater than V2. Remember that. We have seen W is negative in compression. In expansion, V2 इज ग्रेटर देन V1। एक्सपांशन में क्या होता है, V2 बड़ा होता है V1 से, तो डेल्टा भी पॉजिटिव आएगा और वर्क भी जो है पॉजिटिव आएगा एक्सपांशन में। लेकिन यहाँ पे कॉम्प्रेशन दिया है, कॉम्प्रेस दिया हुआ है, देखिए यहाँ पे प्रॉब्लम में। सो रिमेंबर दैट इज वेरी इंपॉर्टेंट, दैट इज कॉम्प्रेशन इज गिवन। सो V1 23 into 10 raised to minus 3 cubic meter, V2 that is 8 into 10 raised to minus 3 cubic meter. Now when work obtained is 4.545, so W is, now remember very important here, W we have to take negative. So why we have to take an W as negative? Yes, can anybody tell me? W हमने नेगेटिव लिया है यहाँ पर। देखिए अगर एक्सपांशन का वर्क दिया हुआ है, अगर यहाँ पर एक्सपांड दिया हुआ है फर्ज कीजिए, तो W पॉजिटिव देंगे। और कॉम्प्रेशन, कॉम्प्रेशन दिया हुआ है, हमने देखा है दैट इज कॉम्प्रेशन वर्क इज दैट इज V2, V1 इज ग्रेटर देन V2, V1 बड़ा होता है V2 से, इसलिए W क्या होगा यहाँ पर, नेगेटिव होगा। रिमेंबर दिस, वेरी इंपॉर्टेंट दिस, दैट इज जनरली स्टूडेंट क्या करते हैं, जो दिया हुआ है 4.545 पॉजिटिव दिया हुआ है इसमें, तो वो पॉजिटिव लेते हैं, लेकिन इट इज रॉन्ग, because we have to read the problem, that is compression is there, condition compression की है, तो work क्या होगा, negative, and it is given in kilojoule, so we have to convert in joule। तो किलो जूल को जूल में कन्वर्ट करना है, तो क्या करेंगे आप, किलो से जूल में, किलो जूल है, किलो जूल से जूल में कन्वर्ट करना है, तो 1000
10 raised to minus 3
माइनस नहीं प्लस रहेगा, 10 रेज टू,
plus 3.
यस मल्टीप्लाई करेंगे 10 रेज टू प्लस 3 से, या 1000 मल्टीप्लाई करो सिंपली 1000 से, तो ये इट बिकम्स दैट इज माइनस 4545 जूल, 4545। ओके, सो दिस इज दैट इज, ये इंपॉर्टेंट देखिए यहाँ पे वर्क। W तो हमने V1 एज इट इज ले लिए, V2 एज इट इज ले लिए, W भी एज इट इज ले लिए, बट वी हैव टू टेक एन हियर नेगेटिव। नेगेटिव क्यों, कि कॉम्प्रेशन, इसलिए हमने नेगेटिव लिए हैं, और किलो जूल में है, बट वी हैव टू कन्वर्ट इन जूल, 1000 से हमने इसको मल्टीप्लाई किए हैं, सो इट बिकम्स that is minus 4545 joule, and we have to calculate that is P. Remaining is same done. Now W formula is same, W is equal to P into V2 minus V1. Now W, what is the value of W? Minus, remember we have to put here minus, that is very important। बच्चे क्या करते हैं, माइनस नहीं लेते हैं, तो आप पूरा प्रॉब्लम रॉन्ग हो जाता है। सो माइनस 4545 इज इक्वल टू P। P आपको मालूम करना है, we have to calculate the value of P। Now V2, what is the value of V2? V2 is 8 into, बच्चे यहाँ 23 रखते हैं, देखिए जो बड़ा है वो नहीं रखना है आपको। V2 8 into 10 raised to minus 3, and V1 23 into 10 raised to minus 3, 10 raised to minus 3 is common। Now 8 minus 23, देखिए आप 15 तो आएगा, बट इट इज द नेगेटिव। 8 में से आपको 23 माइनस करना है, 8 माइनस 23, या 23 में से 8 माइनस कीजिए, और जो बड़ा अदद है, जो बड़ा जो है नंबर है, उसकी सिंबल यहाँ पे आप लिखना है, दैट इज बड़ा कौन है यहाँ पर, ग्रेटर 23 से, 23 माइनस है तो माइनस की सिंबल लिखेंगे, अंडरस्टैंड। सो 8 minus 23, that is the minus 15। okay, so now this on left hand side, this minus is there, minus work, minus 4545, and on the right hand side also that is minus, so this minus minus becomes, क्या होगा ये माइनस और ये माइनस, मैथ्स वाले बता सकते हैं, माइनस माइनस
Cancel होगा.
प्लस हो जाएगा, इस करेक्ट। सो ये प्लस होगा तो हम कैंसिल कर देंगे, माइनस माइनस प्लस हो जाएगा, अब प्लस ही रहेगा, देयरफॉर P इज इक्वल टू, अब क्या कीजिए, क्रॉस मल्टीप्लिकेशन, क्रॉस मल्टीप्लिकेशन करके, देयरफॉर P इज इक्वल टू, ये 4545 एज इट इज रहेगा, ये नीचे जाएगा न्यू डिनोमिनेटर में, दैट इज 4545 डिवाइडेड बाय 15 into 10 raised to minus 3, 15 into 10 raised to minus 3, and if we solve this, ये अगर हम सॉल्व करेंगे, दैट इज we get the pressure, ये -3 को न्यूमरेटर में लेके जाइए, 10 raised to plus 3 होगा, और 15 से ओरली भी कर सकते हैं आप, 15 से इसको डिवाइड कीजिए, 4545 आता है, 15 3 45, 15 तिया 45, और 15 तिया 45, जीरो लेकर हम जो है 3.03 into 10 raised to 5 न्यूटन पर मीटर। सो देखिए, सो ये प्रॉब्लम प्रीवियस से थोड़ा सा अलग है। प्रीवियस में क्या था, वर्क डन मालूम करने के लिए कहा गया था, प्रेशर, इनिशियल वॉल्यूम और फाइनल वॉल्यूम दिया गया है, लेकिन इन दिस प्रॉब्लम दैट इज वर्क डन इज गिवन initial volume, final volume is given, and we have to calculate the pressure. So these such type of problem may be asked in the examination. Now next. Now we solve problems on work done in reversible process. अब तक जो प्रॉब्लम थे वर्क डन इन इरिवर्सिबल प्रोसेस में थे, अब जो प्रॉब्लम सॉल्व करेंगे हम वो रिवर्सिबल प्रोसेस। वेरी इंपॉर्टेंट, ये प्रॉब्लम बहुत इंपॉर्टेंट, ऑलवेज क्वेश्चन इज आस्क्ड। अगर आप क्वेश्चन पेपर देखेंगे तो उसमें ऑलवेज कंपल्सरी क्वेश्चन इज आस्क्ड ऑन दिस, that is work done in, that is reversible process. So you do more practice of this. That is, I will read the problem. 1 mole of ideal gas expands isothermally and reversibly at 300 degree Kelvin from 0.12 cubic meter to 0.36 cubic meter. Calculate work done, delta E and Q. So this is the problem. Now solution of this. So first of all, we write what quantities are given in the problem. So given things. So I will repeat again the problem. 1 mole of an ideal gas, 1 mole, and it is number of mole is given, and a small n की value दी हुई है, small n is equal to 1. गैस एक्सपांड्स, देखिए पिछले प्रॉब्लम में कॉम्प्रेशन था इसलिए हमने वर्क नेगेटिव लिए थे, यहाँ पे एक्सपांड यानी एक्सपांशन इज गिवन, expand isothermally and reversibly at 300 degree Kelvin. So 300 degree Kelvin temperature दिया हुआ है. It is directly given in degree Kelvin. So not necessary to convert again. Remember that 300 degree Kelvin. From 0.12 cubic meter to 0.36 cubic meter. यानी V1 दिया हुआ इनिशियल वॉल्यूम कितना है 0.12 और V2 that is 0.36 cubic meter. So small n is given, V1 is given, V2 is given, T is given. Now R, in this problem R is not given, but you have to remember. Sometime it is given in the problem in bracket, that is R is equal to 8.314 joule per Kelvin per mole. And we have to calculate the value of W, that is work done. We have to calculate the value of W, delta E and Q. So these are the given things. Now which formula is used? That is work done in reversible process. W max is equal to 2.303 nRT log of V2 upon V1. So we have to calculate the W or W max. Max is the maximum. So 2.303 into n, small n. What is the value of n? Small n 1. So we have to put here 1 into R. What is the value of R? 8.314 into T. That is the 300. That is 300 log of V2. V2, what is the value of V2? 0.36. We have to put here 0.36 divided by V1. That is the 0.12. Now we solve this. So W max is equal to 2.303 into 1 into 8.314 into 300 into log. अब देखिए 0.36 divided by 0.12, it becomes 3. Remember अगर हम करेंगे 12 3 36 और ये पॉइंट जो है कैंसिल कर देंगे उसे हम, तो log 3 आएगा. Remember log 3. So W max is equal to 2.303 into 1 into 8.314 into 300. Now this value of log 3. So value of log 3 is, that is 0.4771. This ये कहाँ से आएगा 0.4771? The value of log 3. Log 3 की वैल्यू कितनी है 0.4771. Now do the multiplication of all these. अगर इसका multiplication करेंगे 2.303 into 1 into 8.314 into 300 into 0.4771. So it becomes 2740.53. 2740.53 joule. So this is the maximum work. Now again we have to calculate delta E and that is the Q. So For isothermal process, we have to write directly what is the value of delta E. That is delta E is 0. So we have to write that is for isothermal process delta E is equal to 0. Now again calculate Q. Now what is the equation for first law of thermodynamics? Q is equal to delta E plus W. Now, what is the value of delta E? Delta E is 0. So put the value of delta E is 0 in this equation. So Q is equal to 0 plus W. 0 plus W. Therefore, Q is equal to W. यानी यहाँ पर जो वर्क डन है, वर्क डन और हीट एब्सॉर्ब दोनों की वैल्यू क्या रहेगी? सेम रहेगी. सो वर्क डन एज वेल एज हीट both are same. Therefore, Q is equal to W. So we have calculated W. So this is the 2740.53 joule. So this is the value of that is Q. So in this case, that is the value of W and Q are same. Delta is 0. So this is the problem. Understand? Any difficulty for this problem? This is very important. Always ask in the examination. Okay.
Yes, sir.
Okay. Next problem. Now the same problem. When 2 moles of an ideal gas expand isothermally and reversibly from at 27 degrees centigrade from 5 cubic decimeter to 15 cubic decimeter, calculate the work done delta E and Q. Again, same problem is there. So I will, what is the value of small n? That is when 2 moles, small n is 2. V1, what is the value of V1 in this problem? 5 dm cube. V2, 15 dm cube. And T, that is the at 27 डिग्री सेंटीग्रेड. देखिए यहाँ पे 27 डायरेक्टली नहीं रखना है आपको, आप ये डिग्री सेंटीग्रेड में दिया हुआ है. सो वी हैव टू कन्वर्ट इन डिग्री केल्विन. सो अभी आपने बताया था कि 273 ऐड करना है. सो वी हैव टू ऐड दैट इज T इज इक्वल टू 27 प्लस 273 दैट इज द 300 डिग्री केल्विन. ये रिमेंबर दैट. बच्चे क्या करते हैं? 27 डायरेक्टली रखते हैं प्रॉब्लम में. सो इट बिकम रॉन्ग. तो आपको डिग्री Kelvin में convert करना है. That is very important here. This is T is equal to 27 plus that is 273 becomes 300 degree Kelvin. R 8.314. W we have to calculate delta E, that is calculate, and Q is also calculate. So same problem, that is W max is equal to 2.303 nRT log of V2 upon V1. Now put the values. Small n 2 है, R तो कांस्टेंट है 8.314, T 300, log 15 upon 3. 15 upon 3 that is the 3 log 3. Already we have seen in the previous problem. Same यहाँ पे भी log 3 की वैल्यू ये आएगी 0.4771. So do the multiplication of this. It becomes W max is equal to that is 5481.06 joule. So this is the W max. Now again same, that is for isothermal process delta E is 0. Delta E is equal to 0. Now we have to calculate Q. Q is equal to delta E plus W. Therefore that is Q is equal to that is Q is equal to 0 plus W. Therefore Q is equal to W. So Q is equal to 54. That is here also the value of Q and W are same. You have to write also. this के लिए 1 mark है. Up to this 4 mark. And delta E के लिए half mark और Q के लिए half mark. So this is the problem. Understand? Next. Now when 3 moles of an ideal gas expands isothermally and reversibly at 25 degrees centigrade from 10 cubic decimeter to 20 cubic decimeter, calculate work done delta E and Q. Given R is equal to 8.314 joule per Kelvin per mole. Again same problem. The value of n small n number of mole 3. V1 10 cubic decimeter. V2 20 cubic decimeter. T again it is given in degree centigrade. So we have to convert in degree Kelvin. That is the T is equal to 25 plus 273, that is 298. That is important here. Now R is given, we have to calculate W, then that is delta and Same problem, same formula, that is W max is equal to 2.303 nRT log of V2 upon V1. Now put the values 2.303 small n3 R 8.314 T 298 log of V2 upon V1, that is 20 upon 10. Now solve this. 2.303 into 3 into 8.314 into 298 log 2. And what is the value of log 2? So 0.3010, this, that is 2.303 into 3 into 8.314 into 298 into 0.3010. what this is the value of log 2. log table में देखना है आपको और वहां से ली गई है वैल्यू ये. So if we do the multiplication of all these, it becomes W max is equal to 5152.38 joule. Now again, that is for isothermal process, delta E is equal to 0. Now according to first law, Q is equal to delta E plus W. The value of delta E is 0. Put in this equation. Therefore, Q is equal to 0 plus W. Therefore, Q is equal to W. And what is the value of W? 5152.38 joule. So here also Q and W are same. So these are the problems. Any problem, any doubt from regarding this problem? Yes, ये problem work done in irreversible process is very important. Huh? Always problem is asked. If you see the question paper, always the problem, such type of problem is asked. Okay. If you
Okay, sir.
difficulty, please ask.
Okay, sir.
You write in the chat box. Okay, we'll see in the next video.